Nama is Menti Muhammad Raza and my role in this video is Project Manager and my matrix number is 228843.
Hello everyone, my name is Lee Pei Ying. My matrix number is 229925 and I'm an engineer in this video.
Hi everyone, my name is Farah Patricia. My matrix number is 228822 and I'm a mathematician in this video.
Hi, good day everyone. My name is Ha Hao Yun and my role is a videographer in this project. My matrix number is 229512.
Alright team, we have a suspension bridge to design. Our company really count on us to have this done. So let's break into 3 different tasks. First, we need to find the equation for the main cable. Second, we need to figure out how many suspended cable that we need. And lastly, my favorite part, how to save the money. Sounds good?
Sounds good, boss. But no shortcuts on safety, alright?
Safety is relative. You know what's absolute? Mathematics. Let me handle the first part. First, we'll substitute 635 into the equation, and then we get b equals to negative 600a, and then we'll substitute 305 into the equation again, and then we can use simultaneous equation to get a equals to negative 1 over 3000 and b equals to negative 1 over 5, and then we can get this formula.
Alright, now it's my turn. Okay, so first, the suspender cable spans 20 meters apart and the bridge spans 600 meters. Let's do some simple maths. Okay, so now, the number of suspender cable of one side is 600 divided by 20 and we get 30. But here, the suspender cable need to minus 1.
Why have to minus 1?
Good question. Here, the number of suspender cable need to minus 1 is due to there are only 29 parts, but we only have 30 cables. So, since we have 2 sides, the number of cable need to times 2. So, total we get 58 of suspender cable for 2 sides.
Quick and efficient. I like it. Now let's get to the money part. So, as you can see that we have 3 types of material that we're gonna go through. We have material A, we have material B, and we have material C. Each one of them have a different strength and also have different distance of suspended cable, and lastly have a different cost per meter. Now, we're gonna choose which type of material that gonna giving us the minimum cost for our suspension bridge. First, we need to determine the number of suspended cable needed. So we need to have length of bridge which is 600 divided with distance between the suspended cables for each material, and we have to minus 1. As we said before, the reason. And then second, we need to calculate the length of suspended cable on one side using this formula, and the value of x we can substitute with the distance of each suspension cable to the concrete tower. For the third calculation, we need to calculate the length of suspended cable on both sides. So we just need to times 2 from the second equation, and then lastly we need to sum the total length of suspended cables on the both sides. So for the first calculation that we need to determine the number of suspended cable that we needed for material A, we got the total is 39 cable, and then for the length suspended cable that we calculate using the equation from the calculation number 2, we can get this value, which the x we can substitute with this value from each row, and then for both sides we just times 2 and we get this all value, and the total length of this material A that we needed is this value. The calculation is same for the material B and also material C. So, to determine the total cost of each suspended cable, we need to times the total length with the cost per meter. So, from our calculation, we can see that type C gives us the minimum cost. So, we're going to choose type C as our main material for our suspension bridge.
But are you sure material C is as strong as others? I don't want the bridge to be snapping because we save a few bucks.
Of course, I already checked the specs. Material C is strong and cost effective.
are the perfect balance between logic and frugality. Mathematics approves.
Okay, so apart from the working solution that we mentioned just now, we also have another approach to solve the problem by determining another arc function of the bridge. So first, we have to draw a parabolic curve and label the endpoints as negative 335 and another endpoints as 335. While for the minimum point, we will label it as 0 and 5. The next step is to substitute two coordinates into the quadratic function, which is y equal to ax squared plus bx plus c. So from the graph, we know that y-intercept is equal to 5. So to substitute two coordinates into the function, we will get these two equations. To find the value of a and b, we can use simultaneous equation. So finally, we get b equal to 0 and a equal to 1 over 3000. So here comes our another function, which is y equal to 1 over 3000 x squared plus 5. To determine which material gives the minimum cost, we have to first determine the number of suspender cable needed, which is divided half length of the bridge by distance between the suspender cable. And secondly, we have to calculate the length of suspender cable at the center, which is sub x into the equation to find the length of suspender cable. And the third step is to calculate the length of suspender cable. We need to sub x into the equation to find the length of suspender cable by using the function 1 over 3000 x squared plus 5. Next, we have to calculate the length of suspender cables on both sides. Okay, since we have two suspender cable with the same length on one side, so we need to times 2. And since we have both sides, so we need to times another 2 to get the length of suspender cable. So total, we need to times 4 to get the length of suspender cable. Okay, so the final step is to sum out the length of suspender cable on both sides. Okay, so here comes our solution. And we will get the total length of the material A equal to 1131. Actually, we will get the same answer same as the solution that we mentioned before. So the same solution goes to material B and also material C.
Alright, so here's the plane. This is the function for the arc of the main cable. Secondly, we need 60 suspender cables. And third, the material C keeps cost low at Rm 782,004.
Do you guys know why it's very important for us to have this all discussion?
We know.
It's because we want to build a safe and well-measured bridge.
Solid work team, let's get building.
And don't forget to name the bridge after me.
We just name it Stay on Budget Bridge.
Okay guys, let's go have some dinner.
Yeah, sure.
You want to join photographer?